Okay, hello and good morning, everybody. So this is the HTML and CSS programming lesson, and today's topic is to see how you could deploy your static web application or website project to Amazon Web Services. And to do this, you will need to have an account to the Amazon Web Services. In the previous lessons, I have encouraged you to apply for the AWS Educate program. So hopefully you have done so, and you can access the AWS Educate platform. If you have not done so, then I don't think you can apply here in a minute or two. I think it takes more time. So in that case, it's better that if you just watch the video instead of trying to follow. But if you have the account already here to the AWS Educate, then I suggest that today you try to follow the steps what I do. And then if you have some problems, then we can try to solve them. I assume you can see my screen now. For some reason, the Zoom is no longer indicating with color what part of the screen it is sharing. So I'm not totally sure if you can see it.
Yes, we see it.
Okay. Okay, so when you want to deploy some web pages, and we call these static web pages or a static project, and it is static because if you only have a bunch of HTML, CSS, and possibly JavaScript files, so therefore the project is static because the server is not doing anything to modify those the results what the user gets. So when the user requests any of these resources, be it HTML, CSS, or JavaScript from the server, so the server always gives back the same result. So the result is static. It is always the same. Then if you have a web application where the server can change the result based on some parameters or state of the application, then that is called dynamic application. So today what we are doing is that we are deploying a static application, meaning a fixed set of HTML, CSS resources. So that is an important thing to realize. Then when I mentioned that we are deploying these resources, these HTML and CSS files. So what does it mean in practice? If you do not have that much experience with software development, the most straightforward thing what you might think about is that, okay, I will be maybe moving or uploading these files to some server, and then that's it. But and typically this process of moving or uploading, when you think about it, it means that you are doing it by hand, by manually, that, okay, I will maybe drag and drop these files to some window, and then there they are. And it's a manual process. But that is not the way how things are done in real life, at least not very often, because real web application projects, they are made of typically of thousands of files and possibly tens of thousands or even hundreds of thousands when you count all the dependency libraries what your project might be using, and then the dependencies of those dependency libraries. So manually dealing with changes, meaning that when you possibly update your project, that then you want to move the updated information to your hosting system, hosting server. So manually moving hundreds of thousands of files or just the changed files, it is totally unfeasible. And that is the reason why most common solution to deploy a web application, or at least very common solution to deploy a web application, is to use the Git version control. And that is what we will be doing today. So here I have now prepared a simple Hello World project for this exercise. So it is here in my repository in GitHub. It's called AWS host test. And this is the project that I will be deploying. And now that is the first requirement so that you can follow these instructions, is that you would have a project which you are hosting in a GitHub repository. And you can use my project here today, this repository, to deploy. And just so to make sure that you know what to do and how it works, I will show that how you clone this. So when we are deploying a GitHub repository, it means that we are going to create a Git clone, a remote repository to our server, just in the same way what we do maybe for our local development computer. So here is our project that we want to deploy. So let's see now how we would deploy this. So I would here from the green button, you can get the clone address path. This one here is a button which you can click. It copies it to your clipboard, the path. Then when you have the repository address, you just write git clone and then the address. And this you can do to my project because it's here in the public as a public repository here in the GitHub. So anybody can clone it, but you need to have, if you would like to modify this project here in the GitHub, then you would need to have write access, which you do not have. But that is not required for this exercise, since this is just an example repository for demonstrating how you deploy a project. Okay, so I clone the repository here to my local computer. And now you can see that it created here a new folder which has the same name what the repository name was. So it is AWS host test. All the contents of this repository will now be inside that directory. So now when I list the contents, they are there. Now we can see, I will open Visual Studio Code. We can see what are these files. So here, the HTML file, hello AWS, just some text here, and then a simple single div, which has the class of a box. And then we have a external style sheet, which is this one, which styles the class, the element with the class name box to be a red rectangle. So this is our demonstration project for today. And we can see how it looks like here. So this is the way how the project will look like. This is our test project. Okay. So here, the most important part is that you know that with the git clone and then the repository path from GitHub, this is the command what you can use to clone the project. And by default, when you do not specify any directory, Git will create you a directory with this name and then put all the contents of the repository there. If you want to specify the directory, you can write it here after. This would be now the name of the directory which you want to create. If you want to clone the contents of the repository into this directory, so for example, if I would like to clone the repository contents directly into this directory, this test directory, without creating any subdirectories, then I could go on and put a dot here. The dot means that, okay, to this directory. And there they are. So basically, this is the command what we will use later on in one of our examples. Do you have any questions now about this so far? Or is it clear?
It's clear.
So two things. You need to have your project in a Git repository, and then you will need to know how to clone it. These are the two main things. Okay. Then to the AVS side. Here in our Moodle project, you can find this link. There is now a little bit of written instruction material to help you. It looks like this. And we are going to go through two different ways of deploying our static pages. First one is an Amazon service called Amplify, which is this kind of ready to use box, which is basically operating with the concept of a platform as a service. And by that it means that when you are using this Amplify, Amazon will take care of all the web server configuration and machine configurations for you. So this is quite easy way to use it. This is what we will experiment, and then another way what we will see is to how we can create a virtual machine called EC2, Elastic Computing in Amazon terminology. So this virtual machine in Amazon Cloud, and then we will configure a web server application called Apache to host our application there. This is the second example. So these two examples we will go through today. Now, if you think about these two ways, so are they can they be used outside the Amazon ecosystem? The Amplify is only an Amazon service, so nothing of this what you do with Amplify, you cannot do the same things with any other provider, such as maybe Microsoft Azure or Google Cloud or something like this. They all have similar services, but they all work on their own ways. Then this second example, which is about creating a virtual machine to the cloud. So a virtual machine is basically the same thing as if you would go on and buy a computer from the cloud, and then the computer is empty. So when you're buying the computer, you decide that what kind of components it will have, meaning what kind of specification, processor capacity, memory, and so on. So you decide those things, and then you decide what is the operating system, and then you can do whatever you want with it. You can install any software there. So this is a general purpose virtual machine, and the commands what we do with the virtual machine itself, those are transferable to any other virtual machine environment. But then the way how we configure or start the virtual machine by using the Amazon Web Services user interface, then that is of course only Amazon specific. But in any case, when you know some of these services and their basic concepts, it is fairly easy to use those same concepts and the same idea in the other service providers as well, since in essence they are all doing the same thing. So the UIs might look a little bit different and the logic might be a little bit different, but the underlying main principles are pretty much the same. Okay. So first we need to log into the AWS Educate. I will now sign in here. And it looks like this. There are all these kind of services like content and classroom, professional resources. Let's not go there. But what we are interested in is in this AWS account here. And when we click this orange button here, then this one will open us the AWS control panel. The control panel then looks the same as it would if you use it without this AWS Educate. Okay, and then it says that I have this many credits remaining. So these credits are basically my virtual money, which has been given to me, and this money is valid until this date. If I run out of these credits, then I have no way of getting more of those. So I will need to manage my credits carefully. And what that means is that when I start some services in the Amazon for learning purposes or for development purposes, I do not leave them running, because when you have services running, you will need to pay for them, and you pay for them with these credits. So these credits is your wallet. It's your money in your wallet, in your pocket. So when you are finished with whatever it is what you are doing with the Amazon Web Services, always remember to close the services unless you need to leave them running for some purpose, for example, for returning an exercise. So then you will need to have the services running as long as the review process takes. Okay, I click here. Then it shows this kind of view, your account status. So it shows here again basically the same things. And then I click here on the AWS console. Click. And now this is the view what you get when you are signed into the AWS Management Console, which is the view what a non-educate, like a normal user, would also get when he logs into the Amazon Web Services. So what we have here is that here we can access all the services what are available for this Amazon Web Services, so in the Amazon Cloud. So as you can see, there is a huge amount of these services. I am not familiar with most of these. I know only a small subset of these services. So those are the services there. Then here you can see there are some recently visited services. So these will then, when you visit something, it will show here, and then it's like a shortcut link. Then here will show your username. The username looks like this now because we are using the AWS Educate, which is a system operated apparently by a company called Vocaro. So they are managing our user accounts. Then here, this North Virginia, means that which one of the Amazon data centers we are using. So Amazon has a bunch of data centers around the world. So here you could choose that which data center you want to use. So you can have different services running in different data centers. However, when you are using this AWS Educate, you are only restricted to this US East North Virginia, known as US East 1. So this is the only one which we can now use. But for our purposes, it has no meaning. So it works just as fine as any of these other data centers might work. The only thing what you might see is that there is a certain amount of latency because all the requests must cross at the Atlantic to North Virginia and then back with the response, compared to the situation that if, for example, we would use this Europe, Stockholm, which is very close to Finland. So of course the connection would be, it's faster because the distance is physically shorter compared to the United States. But it's for our learning purposes, it has no relevance. Okay. So where did I have the... Okay, here. Let's put it here. So we are going to do the AWS Amplify thing first. So here are the instructions what you can follow in this document. So log into your AWS console. We have done that. Then we need to access the Amplify service. Okay. We do that. We go here, or I will do it from here. So you should find Amplify. I don't know under which category it is. You can also write it here, amp, and then it shows AWS Amplify. Click. And okay, now it shows a little bit different UI for me because I have already deployed this the same project once. So on the first time when you do it, it should show you like this kind of view what you see here. So here you should choose this right side, the deliver, and click the get started. Here I will click here and use this host web app since I have a little bit different UI. Okay. So then when you have clicked on the get started here on the right side with this deliver, you will see this view. And now it says that, okay, we have existing code and where is our code hosted? So there are these different Git repository hosting services listed here: GitHub, Bitbucket, GitLab, AWS Code Commit. All of these are Git repositories. And then here at last is the deploy without a Git provider, but we will not do that. We will use this GitHub. Here. And yeah, actually now I realize that it might be so that you cannot actually use my repository because in the next phase, it will ask so that it can log in with your GitHub account to access your repositories so that it can then show a list of repositories here in the UI. So in fact, it is so that you cannot use my repository, this repository here as an example. So if you would like to use your own repository to follow this example completely through, what you would need to do is that you would need to create your own repository to GitHub with some example content. What you could do is that you could take these same files and then use them in your own repository. So that is something what you would need to do after this next step, because when I choose here the GitHub and click continue, here for me it says that GitHub authorization was successful because I have already used this service before. But for you, it would then ask that you need to authorize the Amplify service to access your repositories so that it can read, because it will show here in this drop-down, when you have given the authorization, it will show you all your repositories. And for that purpose, you will need to give access to it. So you cannot actually deploy here the repository of someone else, it seems. So I think that we will do now so that let's have a break of 10 minutes. And during that 10 minutes, you should be able to create your own repository to GitHub. Do you know how to do that? Does everybody know? Or will I show how to do it? How comfortable are you with GitHub and Git in general?
We used it in the first study period. I authorized it. It wasn't all hard.
Okay, I think maybe I will show how to do the how to create the repository, just in case if you don't know how to do it. So let's skip the break. Okay. So first thing we must have is that we have the we will create our test project here into our local computer. So I will create here a folder with the name of demo project. You can also create this folder from the by using the your graphical user interface, however you want. And then I will create here now with Visual Studio Code, I have now here this demo project. What is this? And then I will create here one file called index.html. And then I will basically create an empty HTML file and then just write there hello world. So create an empty HTML file. Okay. So that's it. So now we have a folder on our local computer. And then we have a single file there called index.html. And then in that file, we have this very basic HTML file structure. And then in the body, we have only a text of hello world. And then if you open it, it should just show hello world. Okay. So then the next step is to initialize this as a Git repository, since that is the whole reason why we are doing this, that we could have this project in GitHub. So now when I am here in my project folder and I want to start using this as a Git repository, I will need to use the git init command. So git init is the command what you will need to do or execute to initialize a Git repository. So this is a command what you do only one time per repository. So now it says that initialize empty Git repository in this path. Okay, so now we can see with git status command what is the situation in our repository. I'm sure that you are familiar with this status command. But in any case, it shows that we are now here in the branch master. So by default, our repository will have a single branch, the default branch, and the name is master. It does not have any commits yet. So the repository is not tracking any files yet, and it does not have any information of any files. So it is an empty repository. Then it shows here that we have these untracked files, meaning that there are files present in this folder where this Git repository is, but they are not tracked by the Git version control system. So it says nothing added to commit. So we have not added anything to commit to the so-called staging area, but there are these untracked files present. And then here is a very, very helpful hint that use git add to start tracking them. So let's use the git add. We'll use the git add index.html. And where did this debug.log come up? I don't know. I don't know what is this debug log. Anyway, we are interested in this index.html. So with the git add index.html, we have now added the file for the staging area, so that it has now marked so that we are going to commit that file as part of our next commit. So that's the reason why it says that the git status says that there are no commits yet, but these changes will be part of the next commit. This index.html will be used there as a new file. So the command was git add and then the file name. Yeah, we added this file to the staging area here in the Git so that it will be part of the next commit. Okay, then we will make the commit. So our first version, git commit, and then here with m, meaning the message. So we can write here with these quotation marks that, okay, this is the very first commit in with hello world. So this commit message is just in Git something what you can write. To describe that, what is this commit about? And the commit message is there to help you and your possible co-developers and people who are accessing the repository to understand that what was the reason why you did this commit. Okay, so git commit -m and then in these quotation marks, so you write something. Okay, so now we have made the first commit. Git status, it says, okay, we are on branch master and this debug log is still untracked. We are not interested in this. Okay, so now we have a local repository here on our computer. And now we want to move this local repository or we want to create a remote repository to GitHub so that we can push the contents from this local repository to our remote repository in GitHub. So we will go here to the GitHub, and then you will need to be signed in. Then I will go on and create a new repository here. And then I give some name to it. Maybe AWS host test 2. Then some optional description, either public or private. Then now we are going to be importing an existing repository. So we're going to skip these parts. Just going to create a repository. And then here it shows some helpful instructions. So now, because we already created here a repository here in our local computer, and we have commits in that, so it is an existing repository. So we will use these instructions from this chapter. So I can copy here this command. What this does is that it adds a new remote repository to our local repository, and the remote repository address will be this one, and its alias, meaning that its name, will be origin. So then I will execute the command git remote add origin and then the address. It's just nothing about it. Then set the master branch to be main, known as main, and then we will push this branch to the origin, meaning the origin is now the name of the remote repository. So these 3 commands now when we refresh this view, we are already using here in this, we are already accessing this URL of our repository. GitHub shows you this when the repository is empty. Now we have executed these 3 commands. And when we reload, now it should show that here is our index.html file. And here you can see my commit message. If I open this file, you can see that now it says hello world. Okay, so with these instructions, I hope you were able to make a remote repository for GitHub or to GitHub. And now when you have this remote repository ready, in the Amplify service, you need to authorize the service to use your GitHub account to read it, read the contents, read the repositories. And then when you have done that, then you should see your repositories listed in this drop-down. Here are all my repositories. Now when I click the refresh, I should also see my new repository AWS test host 2, and it is here. So I will need to select my repository here in the Amplify, that which one is it that I want to deploy to the Amplify service. And then if I would have multiple branches, I could select here that which branch is it that I want to deploy. In a real life repository, you would have multiple branches. For example, you could have a branch for having the release version, which has only working and tested code. Then you could have separate branches for development purposes, where you might have still code which is not working, it's under development. So you would choose here whatever branch it is where you have your released code. Okay. And then here is an option that are you connecting a monorepo, pick a folder. So this would be an option that if you are having so that you have multiple applications or projects hosted in the same repository, but in different folders. So then this is the option what you could choose. So then it allows you to select a subfolder from your repository and from this branch. But we don't have that situation now. Okay, then we click next. And then it says, pick a name for your application. It will suggest the name of your repository. This is just fine. And then here are some build settings, which would be important if we would need some commands or some commands to be executed before our application is ready to go. That is very common in these days with these front-end web projects when you are dealing with maybe some JavaScript building or CSS minification or some kind of asset pre-processing. But we don't have any of that. We just have a single HTML file. So this is just fine for us. We can click next. And then it says that, okay, please review the details. And if everything is good, we click save and deploy. Okay. Now it is it has created the project and it is now deploying the hosting service. It takes a while. If we click there, we can see some information still flashing here. You can see here the build history. Here is then the domain name of our application. So this is the URL which one we are going to be using to access our application when it is ready. Here it is saying that what is it that it is doing. It is using a technology called Docker to run a hosting server and all its applications. It's using this kind of server machinery. Here we can see what is it doing on the build phase. So it goes through these 4 phases. It goes through the provisioning, which means that it's creating the machine environment, the server machine environment, installing the services. Then it's going through the build phase, meaning that if you would have some build commands, it would do those. And then it deploys, and then there could be there is a verification step to see that is everything okay. And now when all these are in green, now it means that this version of the application is ready to go. Now we can see that. Do we see our application or our site here? Yes, it says here the hello world. And now through this address, anybody could access our site. And this is now the final step in our Amplify deployment. Our application is now in the public. Now, if we would be working with any real-world application, we would need to have a host name. But that is something what you need to usually to buy the host name. So then you would need to configure the Amplify service so that it is using your host name instead of this auto-generated host name. But for these school projects and development projects, this generated host name is just fine. Now we would have a link what we could give to anybody. And in your case, this would be the link what you would need to give to me when you are returning your homework. Okay. Do you have any questions at this moment?
Yes. Is there a way to get around please verify your credit card information point? Because any time I click on anything basically here, it just sends me to verify your credit card information website.
Yeah, so when you create your account with the AWS Educate, you should be given the option of choosing the account type. The account type what you must choose is the starter account.
There was no starter account. I chose student. Oh well. Guess I can create another one. Another account.
Yeah, so is there someone else who has managed to choose the starter account and use this without a credit card?
Yeah, I had it. It worked all fine. Did not ask the credit card in any moment.
Yeah. So if it is asking you to use a credit card or to verify a credit card, then you have selected the incorrect account type during your account creation process. Because there is the option of choosing this kind of normal AWS account where you will need to have a credit card. So with this account type, it will give you these free credits, but it will also ask you to connect your credit card to the account, because if you run out of those free credits, then it will start billing you for the services what you are using.
I have one question.
Yeah.
Regarding our project, should we all upload all the folders, each one individually to the AWS, or is it okay if only one of us does this?
So in the teamwork,
in the teamwork, yeah.
It is okay if a single person does this.
Okay.
So the whole team should return only a single URL, which is their hosted work. But I very much recommend that everybody on the team would practice on how to do this, because it is a skill what is useful for you in the future. So for that purpose, it is a good idea to practice of doing this, and also doing the next step what we will do, which is with the EC2, this EC2 instance. So you will only need to return the application in a single URL for the whole team, but I still recommend that everybody would do it, just so that you can learn, and you are in school because you want to learn, right? And not to minimize your work, but to learn. So of course you will do it. Everybody will do it. I know it.
Yeah, it really seems like there are only 5 options: join, AWS Educate, and then it just says student, US veteran, company recruiter, institution, and educator. But there's no starter account. Yeah,
that option comes once you have chosen the student. So at some point after that, it comes the situation where you can decide the account type.
Okay, and of course I cannot use the same email address.
Yeah, probably so. There is also the possibility that you can contact the AWS Educate support through your existing account and ask that is it possible to delete your account so that you can create a new one with the starter account, or is it possible to change your account type to the starter account?
Okay, I'll do that.
Regarding the Azure, is there like something that we need to do in order to share that as well? Like the actual design?
I didn't understand. What is it that you are asking?
So you had us design the websites beforehand with Azure.
Yes.
Is there like some steps that we need to do in order to share that work as well?
Yes. In the Azure, when you have your work in the Azure cloud, you can make it so that it is public, and then you will have this URL which you can share with it. So if you go with the web browser, for example, to the Azure cloud, log in with your information, you will see your team project there, and then you can modify it so that it is public. The setting is public, and then it is available. This is also one thing which we did here in the class, and I believe there is a record of it in the
Oh, really? Oh, okay. Excuse me then. Okay, fair enough.
So I think you can see an example of this in the last video, what there is available in our YouTube channel.
Okay, thank you.
If you are not able to do it, then contact me later on and we'll see how to do it. Okay, so what do you think about this amplify thing? Is it something, or is it easy to do, or was it too complicated?
It seems simple enough,
Well,
especially with the steps as well. Yeah.
Yeah, I thought it was easy as well. Very, very well done.
Yeah, so the most important thing is to have the project in the GitHub repository, and then you need to authorize access to that one. And when you have your project in the GitHub repository, you must make sure that whatever assets you have, that you cannot have any parts like this. Not any CSS or any images or whatever. So when you are in the beginning, when you are developing this, it's very, for many people, for some reason, they put the full parts on their own computer, and then with their own hard drive letters there, and use this absolute addressing on their computer. And if you do this like this, with this kind of addressing, it will not work for anyone but on your computer, because for these to work, it would mean that whoever is seeing this would need to open the files in their local computer from the same exact hard drive letter, and then from the same exact folder structure. And that is totally unreasonable to expect. And then if you have it like this, it will not work in any server environment at all. So you cannot use this kind of absolute addressing to your own hard drive for any of these assets. Maybe I see this in these courses, maybe 20% of the students usually use this kind of addressing for the resources. So please don't use this kind of addressing. It works only on your computer and on no one else. Okay, so then.
Hi, hello. Sorry, can I ask a question regarding what you just talked about?
Yeah.
So I and my teammate actually shared our work on GitHub, but the problem is when I pull the code from GitHub, I cannot see the images or the what do they call it, the icons that she used on our part of the code. Yes.
Yeah. Well, the reason for that is that the addressing what you are using or what he was using is incorrect, or he did not commit all the files to the repository. So when you are getting, you might only be getting the HTML, but for example, not the icons or not the fonts or not the images, depending on situation. So it is required that the parts are correct. The parts should be relative parts, and then the files must be, of course, present. If the files are not present, then it will not work.
Okay. So So because I tried to do that, but when I tried to upload my own parts, it was telling me that there are too many files. So I guess I have to cut down the files and just probably upload the important ones then.
Okay, I don't know how could you get a message that there is too many files when you are using Git. At least I have never seen that, and I have been working with quite large projects. So I think you have then misunderstood some phase if you are getting that kind of announcement or error message.
Okay, all right, thank you. I'll check it. Yeah.
So double check that what is it that you are actually doing, and make sure that you are actually doing the commits on your local Git repository, and then that you are pushing using the push and pull commands to move the content of the commits to and from the remote repository. That is how you must use the Git and GitHub. You should not use GitHub so that you are using here this add file. So these functionalities here are something what you should not be using on a regular basis. These are something what you should only be using in some exceptional situations. And I personally have never had a situation when I would have used these features, for example.
Yeah, that was my bad. That's what I used.
Okay. Okay. So you were not actually using the Git application, but you were using then these UI features. So
yeah, I was, but I wanted to explain it, so I thought maybe it could be easier to do it with the website instead of having to.
No. It is only easy to use here in the very beginning when you are dealing with possibly one file or something. But if you are using these upload files, then you are basically defeating, let's say, 90% of the whole reason why you would be using a version control in the first place.
Yes, true.
So if you are using these features, it is the same as you would use, for example, Google Drive or a USB memory stick or email maybe to share your files, or Dropbox. And in any programming projects, using those in any long-term ways and in a team environment is basically total madness, so to say, because it gets so difficult to manage when you have more files than let's say one or two.
Okay.
Because
all right, thank you.
Because what the main benefit is, that what the Git version control system does for you is that it monitors all the changes, and it allows you to basically to, so to speak, to send and receive changes from your teammates with 0% chance for missing files, and also it does this totally automatic, so you don't have to think about 1 second that okay, what were the files that I just modified, what are the files what I need to send to my teammate. So that kind of thinking the Git takes totally away when you are using it in a team environment. So the idea is so that everybody on the team, you have a local repository of the same project, and you have a remote repository, for example, here in the GitHub. So when person A makes some modifications, he makes the modifications, he creates a commit out of the modifications, then he pushes the changes to GitHub, and then all the team members can pull the changes from GitHub to their local repositories. And all this is an automatic process. Only what you need to do is to execute these commands, and the Git will do all the things for you. So that is the way how the Git is supposed to be used. But yeah, you are still practicing it, so it's totally understandable if you get some confusion. The Git is not maybe the easiest program to use or to understand in the beginning.
Thank you.
I don't know if you are familiar from your previous studies, but here in this Git SCM page, which is the homepage for Git, is this documentation, and then here is this Pro Git book. which you can read it for here in free or download PDF or EPUB versions. So when I was teaching the Git version control basics, this is something what I had as a mandatory reading. So here, these chapters, 1, 2, and 3, and then 5 and 6. These are the chapters what you should read and understand so that you are able to use Git on your local machine and then use GitHub to your advantage and then use Git in the team. Then these other chapters here, they are some more advanced knowledge, and Git on the server is something what you don't need to know at this moment. It relates on that how you can set your own remote repository server, similar partly similar to what GitHub is. So if you are uncomfortable with Git, I really recommend that you would read these first three chapters and then chapters 5 and 6. I think it will help you greatly on understanding on what you should do in each phase with the Git and why is it working or doing something in each phase.
May I ask you a question?
Yeah.
How can I log out my web service in AVS? Like log out?
Log out.
Yeah.
In any case, this AVS console in the when you are using it through the Educate system, I think it has a 2-hour timer. So after 2 hours, it will automatically log you out in any case. But then here is a sign out button, and then you can sign out there. But just closing the tab is fine. There is no harm in leaving the session open, since in any case it will log you out in 2 hours. So when you are working for a longer time with this AVS Educate, you will see situations where it suddenly stops working, and then it has the session timer has expired, and then you will need to log in again through the AVS Educate system. Okay, let's have a break before we move on to this part. Let's have the break of about 30 minutes or 25 minutes. So we'll continue at about 9:30. And then we will start on the EC2 part. And if you did not manage to do this AVS Amplify, then here should be a pretty complete step-by-step instructions for you to follow. So you now have time to do it. Okay, let's have a break and then continue at 9:30. Okay, let's continue then. Now we will continue with the EC2 instance with Apache Web Server. Let's see, am I still logged in here? Yeah, now it says that my session has expired. So this is the situation what you get every now and then. The session timer is quite short here. This AVS Educate, I think it shows here. Now I need to click again the AVS console. Okay, so now with the EC2, I can find it again from here from the service. So this EC2 means elastic compute. So these are they are general purpose computers which you can basically rent from Amazon Cloud. And then you can do whatever you want with them, because they are indeed general purpose computers. So you can install software there, and then you can write software and execute that, and you are just paying for the computer rent. So this is how it looks like. Here on the left side, we have this kind of EC2 control panel. And then here in the center, this dashboard view, which shows the overall situation of your EC2 situation. And here this instance term means now basically a single virtual machine, virtual server. It shows here how many computers you are running, and then how many you have in different, all states altogether. You can have these computers, they can be running, or they can be in this kind of sleep mode where you are not paying for them, but their state and data is saved, and then you can resume those, and then again you will start paying. Okay, so if we see what it says here, what is the first step? So first step is to create a so-called security group. Oh, here is incorrect wording. So security group. So basically, the security group in these EC2s, it means almost the same thing as what a firewall would mean for your local computer. So security group is what controls that. What is it? What kind of communication can come in from the network, and what kind of communication can go out from your computer. And here from the network security groups, here you can find it, the security groups. Here I have already some existing security groups, but what we will do is that we will now create a new security group for our web server computer, which we have not yet created itself at all. So here we click on the create security group, we get this kind of view. Then we need to give some name. This is some name what we can use to identify it. So I'm gonna put it here, HTML CSS class demo. So this is my name. Then you can have some description. What we will do is that we will allow incoming HTTP plus SSH connections. So this is what we will do it with it. Then here is this that to which so-called VPC, virtual private, I don't remember what the C stands for. In any case, this VPC is kind of like a network configuration. So you can create networks into this Amazon infrastructure, Amazon cloud, and then into those networks you can then create services, and then you can control how these networks, how they can communicate, and how the services inside those networks can communicate. You will always have, when you create, you will always have a single default VPC. So that is what we will use. Let's not touch here. Then we go here, inbound rules and outbound rules. These are now basically the firewall rules what we control. So what we want to allow to outbound, meaning from our server to the world, we will allow everything. And then from the world, from network to our server, let's add, here we can add these protocols. Let's add HTTP. And we do this because we are going to be setting up a web server. So of course we need to allow the HTTP protocol. Then we could define that where do we allow it from. We could define that we allow it only from a certain IP, or maybe a range of IPs, or anywhere. We will allow anywhere because we want to have a public server. Then what we will also need to allow is that we allow SSH, secure shell connection. So basically that we can have a text-based command line access to our server. So we will create our server to be running with a Linux operating system. And there will not be any kind of graphical user interface with our computer. We will only have a command line based access to it. And we will use SSH connection to access it. Now, for added security for this SSH connection, what we will do, or at least I will do, you could select anywhere. So anywhere from the internet, anybody could connect with SSH to our machine. Of course, you will need to have credentials as well. But we can do an added security step by setting just so that we allow connections from my IP only and nowhere else. So only connections coming from my IP, it will auto-detect your IP, will be allowed. And now notice that if you are using this kind of normal internet connection and you don't have you have not bought a fixed IP from your internet service provider, your IP address will change every now and then. And if you have selected here this my IP in your EC2, it might be that tomorrow your IP is no longer the same. So then the EC2 with this security group would block the access. But then you can go on and update the security group again if you want to do so. Okay, so with these two inbound rules, we are good to go. We have the HTTP, we have the SSH. We can allow all traffic from outbound. Then we just click here, create security group. So now our network firewall is basically ready. Okay. That was the step what was described here. Then we will go on and create the actual EC2 instance. I will go here to the EC2 dashboard. And then here is the launch instance. Here it shows two options. This template is now disabled because we don't have any templates. So template is basically, it is a machine configuration which you have created sometime and then you have saved it so that you could reuse it later on. But I don't have any templates, so it's disabled. So click launch instance. Now we are choosing a machine image here. There are basically what we are choosing here is that we are choosing an operating system and then some default applications. As you can see, there are these different operating systems here, Microsoft Server with SQL Server installed, some deep learning, Microsoft Server configuration, then different flavors of Linux operating systems. And what we will be choosing here, okay, Mac OS, this is also a bit new. I think this wasn't, some months ago, this wasn't here. Okay, in any case, we will choose this first one, Amazon Linux 2 SSD volume type. So this is the one which we will choose. Then you could choose that what kind of processor architecture do you want for your computer. Shall it be x86 or shall it be this ARM-based architecture? For our purpose, this doesn't have any meaning, so let's just go with this x86. So I click select. Then I could choose an instance type. So this now decides that what kind of capacity this has regarding processing capacity or memory or network performance. And as you can see, there are these. There is a pretty huge selection of different options. This column indicates that how many virtual CPUs, so basically how many processor units your computer would have, and what is then the internal memory. So there are pretty big monsters here. 768 gigabytes and 96 processors. and stuff like that. 128 processors with 3,904 gigabytes of memory with 25 gigabit network connections. So for really heavy processing. But I would advise against selecting these if you don't have any purpose for this, because their cost is quite high, so you will need to pay for them. If you are using the AWS Educate credits, these will eat up your credits quite fast. And if you are using your own money, well, you can do whatever you want with your own money, but you will end up paying quite a lot of those. The pricing is not visible here. The pricing is visible in some other view. But what we will choose is that we choose this one, this T2 micro type. It has 1 gigabyte of memory and 1 CPU, and this also this so-called free tier eligible, which means that for the first 12 months, if you would be using the credit card version, then you could get 750 hours of free computer time with these instances each month, but that's only for the first 12 months. But in any case, this is just fine for our purpose. Then we will click here, configure instance details. How many we could set here. We could also set start 1 or 100 of these computers. Then here is an option to so-called auto scaling group. We could also do that, so that if we would be running some kind of application, for example, some web application, we could configure auto scaling parameters, which mean that if the load on our application, meaning that if we would have a huge number of sudden users, then this auto scaling would create new web server instances automatically, depending on our parameters. So we could do it so that by default, we have only single web server running. But then if the load on that computer increases to a certain point, then new web servers are started automatically by Amazon. And therefore the performance of our web application from the user point of view would remain good. But for this demo, we don't need to do that. Then here are these spot instances. There is kind of a possibility also that if you have some processing activity, what you would need to buy computing power for, if you don't need it now, meaning that if you have some kind of calculation operation, for example, to execute, then you could enter this kind of bidding contest for these spot instances, which mean that the pricing of the computing power is changing per hour, I think, depending on the demand on Amazon infrastructure. So when the demand for their infrastructure is lower, they will lower their prices to get more customers through this spot pricing. So this is one thing what you can do if you have need for computing capability in the near future, but not immediately. Then here we could select that what is our network, this VPC. Then these networks can be split into these so-called subnets. We don't need to touch this. Then here is that, do we want to auto-assign a public IP? Here it says that, yes, this is now enabled. So our computer will get a public IP. That is exactly what we want. Then this placement group. Okay, I'm not familiar with this term. And then this domain join, not really that one. This IAM role. These IAM things, they are this means that you can create different this kind of access role sets here in this Amazon Web Services. These different roles have different capabilities. So some role might only be able to read some information. Some role might be able to create some new information, or for example, to create new EC2 instances, for example, or delete existing instances and so on. So with these IAM roles, you can play around at what kind of access level each service and each user in this in your organization has. But since we are now a solo organization, we don't need to play around with this. Then here is about some shutdown and hibernation behavior. We don't need to think about this. But what we should do is that, okay, where was it? I need to check it out. Network, yeah. And then, okay, I think it comes after this. Yeah, here is this step number 6, configure security group. So for this chapter 3, we don't need to do anything. It's good to go. Add storage. The default setting here is just good. It is adding an 8 GB storage. Then add tags. These tags, we don't need to do anything with them. Then here is our security group. So basically what is the firewall settings for this computer. We could create here a new group, or we can select an existing, and this is what we want to do. Here is the one which I just created, so I'm gonna activate that one. So now my machine is using this security group. Okay, then we are good to go. We have chosen the security group. We review. We're going to be launching an Amazon Linux 2, T2 micro instance, then security group, which we created earlier, and launch. Okay, now we get this kind of dialog. So select an existing key pair or create a new key pair. So these key pairs, they are a concept which allow us to log in with SSH connection to our EC2 computer. So the login process in the SSH in these EC2s, it does not go through the traditional username and password mechanism, but it goes through the this kind of public private key system, which means that it is basically a software equivalent of a real-world physical key. So it means that the access to the computer will be restricted, and only the person with the correct key, so in the same way as you have keys to your house, for example, so only a person who has the key to your house door can enter the door. So this is the exact same thing, but for network communications. And here they want to remind you that this you can get the key to your EC2 instance here, but they remind you that this is the only time when you can get access to the to this key. So it is your job to keep the key secure and available. If you lose the key, you will not have the ability to log in to your EC2 with SSH anymore. So this is a very important concept that you must pay attention to these keys. It is the exact same thing that what a physical world key is, that if you lose the key, you cannot get in without the key. So here is a possibility of choosing an existing if you have previously created one, but we will go with the create new key pair. Now it asks for a name. I'm going to put here HTML CSS class demo. And then when I click here, download key pair, I get this kind of key. And this is now the file. What is my key? This is securing this and keeping this available is of utmost importance. So for example, for any school project, if you lose, for example, your key, this one, you cannot access the project computer anymore. And no teacher from the school can do anything for you. You cannot contact Amazon customer service and ask for a new key. They cannot give it to you. It's physically impossible. So you must know where you put this key, and you must keep it safe. If this key leaks to people who should not have it, then your application is in big trouble. And in real world situations, this can have a really big implications. Okay, now launch. I have the key, so let's launch the instance. So it takes a while when they are launching. Then it says that we could create these billing alerts to get email notification that if the costs exceed some level. But at least some time ago, these billing alerts were not available for these starter account type of educate users. So to have this billing alert to work, it requires that it has the credit card is in use. Okay, let's see what is the situation with our instances. It says here initializing, they are setting up our computer. When we click here, we can see some details. Here is the public IP address, which we can use then to access it. Here is the public domain name. So this is what we can also use to access this one. Again, if we would have some domain name, which we would have bought, we could connect it to this one. But for these development purposes and school purposes, we are not buying any domain names. Let's see, here is the refresh. Did it already start? Yeah, I think it started. Okay, so now we can connect with SSH to it. If you don't have any SSH program on your computer, there is, for example, PuTTY, what is good for Windows. If you're running a Mac computer, then I believe there is a command line SSH installed. So here you could download this PuTTY. There are also this bitwise SSH client that you can also use. But I will be using this PuTTY here on my example. And when we are using the PuTTY, we will need to convert this our access key to a different format as well. And there is instructions to do how to do so here in the document. So if you don't already have PuTTY or equivalent, I recommend you download it. Okay, so we are now here. Here is about the key pair thing in this documentation. Here is a link where this key pair thing is explained in more detail. And then what we will need to use is that with the PuTTY, if you are using the PuTTY SSH client, we will need to convert the key into different format. And there is a tool called PuTTyGen, which comes with the PuTTY. So I will open it now. Here is PuTTyGen. This is a key generator application, so I will load. Now I will go where my keys are. By default, this PuTTY is looking for keys with the PPK. But now our key is not in that format. It is in PEM format. So we need to choose that. Here is my key. And then it says successfully imported. To use this key with PuTTY, you need to use the save private key command. And here is the button to do so. When we save the key now, it will be saving it in the PPK format. So this does the key conversion. And then save. So with this PuTTY key generator application, PuTTyGen, it was here. This is a tool which comes together with the PuTTY application in Windows. So with this, I first loaded the PEM key, and then I used the save private key to save it in the PPK format. Now I have the key in such format that I can use PuTTY to access my EC2 instance with SSH connection. So I will now close the PuTTY key generator. Next step is to open up the PuTTY program. Here, I now need to configure that what is the host name or IP address where I want to connect to. I can find it here. So here is my IP address for this instance. This is the address of the computer where I'm connecting to. I put it there. And then, because this EC2 instance is now using the key pair login system, so I need to define my key before I open the connection. I do it here under the connection, SSH, and auth. Here is a field where I can define my private key for authentication. Now I need to find, and it is here. This is the key where I just created with PuTTY. It is in the PPK format. And now it is listed there. Now I'm ready to open up the connection. So here in the PuTTY, you need to define two things. First, the address where you are connecting to, and then here in the connection SSH auth to this field, you need to put your converted key, and then you are good to go. Now I click open. Then it warns me that this is the first time when I am connecting to this one. Do I trust the computer? Yes. And now it asks that what is the username what I will be using to log in. And the username is always, it is listed also here in the document. It is like this, EC2-user. So I will write here EC2-user. Hit enter, and it says authenticating with the key. And now I am now I have access to the my virtual machine in Amazon Cloud, and it is running now the Amazon Linux 2. And now I can start to do whatever I want with the computer. Now, because in this case, what we wanted to do is that we want to run a web server here so that we can host our static web page. We need to install web server application. The application what we're going to install is called Apache Web Server. This is an open source web server, and this is very commonly used. It has been around 25 years. So it is quite mature product. There are, of course, another web server applications as well existing. One popular is NGINX, for example. This is also a web server application, and it also has other features as well. And then there are other applications as well, but the Apache and NGINX are maybe the two most common and biggest applications. And these are quite feature-rich applications. So there is lots of different features what they have, and lots and lots of different configuration options. What we are going to be doing is that we are going to be using the Apache web server in its default configuration. So we will not be modifying the configuration in any way. It's unnecessary for our case. So what we will do here is our command line, and then here in the guide document, under this heading that configure the EC2 instance to run the Apache web server, here are some commands what we need to execute. So we are going to execute command sudo su. This means that we want to use so-called super user elevated privilege level for all our commands by default after this command. Without this command, you would need to put the sudo in front of all the commands what you execute. So when we execute sudo su, we spare ourselves of that. So now with the super user access rights, we can, for example, install applications to the operating system and access files and folders which would not be allowed with the normal user privileges. So in these Linux operating systems, there are these user privilege levels, and default users don't have access, for example, to read certain operating system directories or to modify them. So you need always to elevate your access level if you want to do that. So it is the kind of the same thing as in Windows. These days you have the run as administrator option in certain situations. Okay, so then we are going to execute command yum update y. So the yum is now an application repository for this Amazon 2 Linux. So it is kind of like the App Store for this operating system. So where we can install and then update applications from that App Store. So we are first going to execute the update command so that we have all the latest information of the contents of the repository, and then it also updates our already installed software to the latest versions. The -y means that we are saying yes to all. If you don't have this -y at the end of these commands, it will ask you that are you sure, yes or no. But with the -y, you are saying that yes, I am sure of everything. Okay, so the next command then is to install httpd. I think stands for HTTP daemon. So daemon is like a term for an application which is running in the background in the Linux. This will install the Apache web server. So yes. Okay. Then we will also install Git because our application is in GitHub. So of course we will need to use Git to use it. So install Git. There it is. And then we will start the web server software by executing command service httpd and start. Okay, so now it should be running. And by default, the web server is looking for content in the so-called root directory. And the default path for the root directory is this, seen here. So to give our web project for the web server to host, we will need to put our project files to that root directory. So in the var www and html ls lists the contents. It is empty, so we don't have any HTML or any files to host in our web server. This is the root directory of our web server. So here it is where it is looking for files when there is any request. So we could create here new files, for example. But now what we're going to do is that we're going to clone our repository from GitHub. So git clone, and then here is my repository path. Now you would of course put your repository path instead of this, and then I will use the dot path here at the end, so that I don't want Git to create any subfolders for the repository, but I want Git to clone the repository right into this folder. Then hit enter. Okay. ls. Now we can see there are these two files. Okay. Now we have some content in our web server root directory, and our web server should be running. So now we can test it. We can go to our EC2 dashboard, and here use the open address. I think it will open up a new, hopefully a new tab for us. Hopefully it worked if everything went okay. Well, it seems quite kind of bad. Okay, it didn't go well here. Okay, for some reason it's not now connecting. Why would it do that? Did I forget to do something? Let's see here. I have set the security group. At least I think I set it. Let's see. It has here, so why can't it access it? It should allow HTTP inbound, outbound all traffic. Yeah, the chances for errors increase dramatically when you need to do everything manually compared to the amplify situation. So now I can't say what is.
Sorry, what was the username that you used to log in?
So the username is visible here. It is this EC2 dash user. So that is the username. Why doesn't it now allow us access? Let's see here, I have an earlier. So inbound, outbound, it's exactly the same. Inbound, outbound, running. There is no response. The Apache has started. So it is like, for some reason, it is now not allowing a connection to the server, but why is that? Why is that now? Yeah, I had just copied the address wrong. It seems. So yeah, I typoed the address here. I had missing the last last section of the IP address. Okay, so now yeah, it was working all along. I was just typoing the address when I copied it. Great mistake. Okay, well, in any case, here is now our application running in an Amazon EC2 instance. And this was the target situation for us. So now we have reviewed the two ways, or two different ways. There are still more ways how you could deploy a static application into Amazon, but I think these are the two most common situations, that you are either using an EC2 or maybe you are using the Amplify service to deploy an application, a static application. And as you saw, this EC2 approach is much more complex compared to the Amplify, because here with the EC2 you are indeed dealing with a general purpose computer, a virtual machine, which you must configure yourself correct so that it is operating as you want. Compared to the Amplify, which is like a platform as a service, you just need to point it to which repository you want to host, and then maybe give some build commands to it, which in the case of static site in our example is not needed. So the Amplify is super easy, but then this EC2 gives you much more flexibility, and direct control if you would need it. And this document should cover all the steps needed to create the EC2 with the Apache Web Server, and then for the Amplify hosting. Do you have any questions now at this moment? Did you manage to follow this EC2 creation or not? In any case, this lesson will be available in YouTube as a video. Sorry, what did you say?
It was easy to follow. Thank you. Okay.
Yeah, so this document is available in our Moodle site, and then the recording will be available later on in the YouTube, so you can check it out later if you did not get it to work.
Yeah, I don't still get anything working there, even though I've been trying to change it to the starter account.
Yeah.
Oh well, I guess I need to try to figure it out after the lectures.
Yeah. I think you should contact the support of the AWS Educate or Amazon, and then ask them to change your account type.
Yeah, I'll try that.
Yeah. Then there is a question in the chat: how do you shut down your server? So here, when you are reviewing the details of your instance, here's this drop-down instance state. So stop the instance will stop it, but it will not delete it. So it should say, let's see. It should say here that it stopped. Let's see in the dashboard. Running. Okay, now it says 0 instances running, and this one is in. Okay, well, it's in state dash, not in the running. Okay, here it says state stopping. Okay, so now it's stopped. So now if I try to access this one here, there is no response from it because the server has been stopped. And when you have stopped, then you are not paying for this instance. If you have reserved a large amount of disk space, then I believe you are then still paying for the disk space. If then you would like to restart this, you select it, and And then where do you start it? Here. Then you start the instance. This starts it again. If you choose to terminate, then it will delete the whole computer, and all your settings and all your files on the disk will be lost as well. So this is where you do it. Okay, let's now have a break of 15 minutes, and after that we'll continue with your home exercise with the breakout rooms. So the deadline is on this week, Friday. So you still have some time to work on the HTML and CSS implementation. And if you have not yet started, then now is the time to start the exercise. And then you should have it on a public server here, either on the EC2 or Amplify in Amazon Web Services. So I really recommend that you give a shot of this sometime before the deadline, so that you don't leave it to the last minute, the hosting system. Okay, but let's have a 15-minute break, and we continue at 10:35. I will now stop the recording as well, since there is no new content coming.